Get going. First off, welcome everyone. Thank you for coming to my talk. My name is Jakob. I'm the co-founder and CTO of Radiant AI. At Radiant, what we do is we help companies such as MongoDB put generative AI into production use cases. Before Radiant, I spent most of my 20s working for Palantir Technologies and working with large enterprises and government institutions such as BMW or the NHS and helping them make data production and enterprise ready and drive decisions through data. And what I want to talk about today is what it means for generative AI to be in production and in an enterprise context. And often when people think about that, they have sort of a misconception of what enterprise ready means. And so I want to start off with a quick definition of like how we think about this at Radiant and also why this is critical to think about it, especially in the context of GenAI. And so when you ask yourself, okay, what does it actually mean that my software is enterprise ready? And you can see out in the market and you can go and check different like offers. And what you see is often that people look for very much like a box checking exercise, where it's more about like user management, audit logging, integration with existing systems, but also the ability to customize it for an enterprise organizations, which are usually large organizations that have thousands of users and that will use your applications in a critical environment where they drive revenue, but also where in the limit, lives could be at risk if any error happens, and it could be catastrophic. And so for me, and for us at Radiant, things like SSO, audit logs, and integrations are just the table stakes that you need to get into the room. But what it's actually about is the ability to deliver the software and deliver your solutions reliably, such that the critical systems can depend on them, but also at a scalable way where they can run inside a customer's environment without having to be intervention, and they can scale up with load and then adjust to that. And when we now look what GenAI thinks about what enterprise ready means, we can see that like Poe, the core AI assistant, is actually like agreeing with me here, sort of also in terms of the priorities and also in the breadth what it means. It's not just about like adding a little bit of SAML integration or adding a little bit of security posture to your application. It's actually about thinking through, okay, how does the application that you're developing, especially with GenAI, how does it work at high scale and reliably day in and day out in an environment where you might not actually have access to debug everything easily. And so with that, the problem is, what does it actually mean for GenAI? Because there is a fundamental problem that I think we've all seen now with LLMs, because LLMs, because they're models, they're based on weights, are fundamentally stochastic. What that means is there is no logic that you can go debug, where you can retry things easily, and where it's very clear from any given input, you will have a deterministic output. And so there's like all these examples online which you've seen. For one of the most prominent one was like when Google launched Gemini, they lost billions in market cap because Gemini actually hallucinated an answer that wasn't correct, and it was seen as like, okay, this Gen AI chatbot is actually not trustworthy. And what's interesting, even like the aforementioned Poe actually promotes like the competition when you ask him about what is the best chatbot, and actually also has like severe limitations in terms of the knowledge it had when it answered this. And so that is a really difficult problem because you don't have a clear answer what will come out of the model when you put in. You will have a good chance the answer will be relevant, but there's no guarantees about it. And when we talk to our customers about this, and when we talk to like industry partners here, then there often comes the question, oh, can we not just turn temperature to zero? Can we not just like turn everything off, make it deterministic, and then we get rid of this like stochasticity, then we can work around this. But what we see is that on the one hand, when we rely on LLMs that are provided by third-party APIs, these LLMs might be changed or might be updated similar to any microservice without you knowing about it. But also, small changes in the input can have radically different outputs. This is a very trivial example, but what you have is that like there is, for example, here I've just added like 2 extra white spaces at the end. We can see that even at temperature 0, we get different answers. And I think this hints at something that is much more fundamental, which is that these LLMs actually don't have an understanding of what is true and what is the right answer. And Andre Karpathy, who was the head of AI at Tesla and then worked both a founder of OpenAI and then worked again at OpenAI, he has this beautiful metaphor that like LLMs are always hallucinating, but we only realize this whenever it hits up on our reality, and that's what we then view as unreliable. And so the unreliability problem is not a problem of like sometimes it gets it right, sometimes it gets it wrong. It is much more around like how do we steer the LLM output to be grounded in a reality that we know and that we can verify against. And we see this, as I said, with LLMs, it's very inherent to the technology, but actually this is not necessarily true because we've seen this before, and everyone who's worked in cloud when it first came out has seen how unreliable it was when it came out. Similar with like large scale big data pipelines, it was very much like these systems end up being extremely complex, which makes it really hard to reason about how they will operate, especially in a failure scenario. But then the industry has always responded and built the right technologies, such as observability tooling for the cloud and a microservice architecture, or reliable, repeatable data pipelines in Databricks and Snowflake or in Apache Spark to actually enable the ambition that came with the technology. And a very good example of this is that when the first microchips were developed, they actually were really unreliable, they were very expensive, and they didn't actually calculate all the time. Nowadays, we take the accuracy for completely granted. And the interesting thing here is this is in large part due to the Americans deciding to go to the moon, buying 60% of the total production of microchips in the 60s, and actually driving that technology to be reliable and to work at scale. And so what we deeply believe in is that we have to build the next software stack to allow LLMs to work at scale. And before we talk about that in a little bit more detail, I want to spend a little bit of time around like, what are we actually doing today? What are we seeing out there in the market when we talk with clients, when we talk with our industry partners, when we conveying surveys with practitioners who have put LLM applications into production. And what we're seeing is broadly two trends. First, especially developers are prone to like take the playbooks they know from software development and applying it to LLM. And this, on the face of it, does not seem like a bad idea, because what you can do is you can just put a prompt into your unit tests, or if you don't want to pay for every a prompt call every unit test, you can also do it in continuous integration. You just ask the LLM to answer a question, and then you have a second LLM or another version of the another system verify the answer. And that works on the face of it, often like in the initial phases quite well. But as these systems grow and they become more complex, what we find is that often it is challenging to actually ensure that there's enough test coverage, especially for things that you don't know about when you build the software, and you end up like essentially continuously evolving your continuous integration system, and it's never really done. And we essentially end up combining two pieces of uncertainty, because the other problem you might have is that the LLM that is evaluating in your CI time is also unreliable. And sometimes you might have things go through your tests that you actually never wanted to ship to production. And the other track we've seen is like telemetry, which is like your observability integrations. It's tracing, it's understanding what do the interactions look like, what are the logs look like. And this then allows you to go and actually understand at scale how your LLM is answering. And also, for example, understanding if a service is down, if it's not responding right away, if it's taking a very long time. But there's another unique challenge with this when it comes to LLMs, which is that LLMs often fail in non-obvious ways. What I mean by that is that an LLM is not like a microservice that all of a sudden takes a very long time to respond to a P99 or throws an error in a database. It might answer to a user given question, or it might do the JSON formatting that you ask for it, but the response might not be quite correct, or there might be little problems with it that you don't really catch when you just apply like numeric observability here, but you actually need to understand deeper what the responses are and how they work. And so that is what we've seen with the developers, where how they like try to wrangle with that problem of like the uncertainty. Then the other side of the coin is bringing in machine learning practices. What I mean by that is that basically we bring in evaluations, we build test sets, we build validation sets, or so-called golden sets of like, these are the good model responses, good model interactions we want to promote. And also we build evaluations such as we compute F-scores, recall, precision to actually get a handle on like, okay, how is this model performing, as well as then going in and versioning our prompts and models themselves and trying out different versions at the time at build time to see, okay, is it working over time? And again, this is something that handles some of the problem. And we have the same challenges that we had with models before, like your classic neural nets that were running like something like YOLO to do object detection, which is like the challenge is not so much like getting it right or getting it to pass your validation set. The challenge is once you have done this, once you've shipped it to thousands of users, once you running it in production, what you need is something that then actually continuously evaluates if it's actually working, if you're giving the right answers, and if your model is behaving or not, especially when this is only a handful of cases and there's like 99% of the time it works fine. So with that, the question is, we have now brought in like developer techniques, we've brought in machine learning techniques. Is it enough? Is it actually working? Are we at a point where we're shipping reliable generative AI application? And just this week, there was an interesting blog post that I highly recommend everyone from LinkedIn about their GenAI effort. And they have this really telling line where like it took them a month to get to 80% of the experience. And from that, they extrapolated that within like another month or two, they would actually be able to like handle the rest. What they found was that the complexity of solving the rest was growing exponentially, which meant that it was harder and harder to do this, especially as they were changing prompts. New problems kept appearing. And it's kind of like a system where you try to bug fix it, but every bug fix might introduce another bug. And so there is this problem that like we're sort of getting to a good version of like an initial first version, but then actually getting to something that holds up to production scrutiny is not trivial and it's actually really hard. And there is all these open questions that we then have to wrangle with, which is like, what happens if your data changes? Most systems will have data drift over time. How do you test your different models in parallel and at scale and ensure that you only roll out models that you can actually trust? And then more importantly, what happens, like, for example, right now, a lot of companies are switching from Llama 2 to Llama 3 as their base model that they then want to fine tune on. Do all of your previous evaluations still hold up, or do you have to write them from scratch? And when we talk to our customers about this and people we work with deeply, they all had the same problem, which is that like they want to stay on the model even if it's less powerful to ensure that they don't have to rebuild everything from scratch. And so that is where we find ourselves now. And the consequence of this, I think we all have seen. One is that a lot of GenAI solutions are actually not rolled out for production. Companies are holding off of this because they're scared of the reputational risk or that things will not reliably work at scale. And so they keep them as experiments. They keep them with like a lot of warnings. They're sort of like more toy examples than they could be if they were applied in production. They invest a lot in human reviewers, and often we find this especially with customer service, that the promise is, okay, it actually needs you to have less human reviewers. But often what companies find today is like an initial bump they get where they can handle more queries, but then it very much tapers off very quickly. And then they have to invest not in human reviewers to review support tickets, but to support the bot that supports support tickets. And so this is sort of this convoluted problem where like, okay, we now have just humans patching the models bad responses. And the other one is you get sort of these whack-a-mole fixes. And I think we've all been through this where like you either think you're monkey patching the prompt and you're literally telling it like, these are good examples, these are bad examples, these are things how the model is supposed to respond. Or you even go so far as to fine tune your data, but then you roll out the new fine tuned model to production and you realize, okay, now a handful of cases that worked before are now broken, and now I have to like sort of try to find a middle ground between the two, and you don't actually have sufficient data to tell you if a fine-tuned model is better than before. And so often what it leads to is like when we talk to people who and like companies we help with who actually have GenAI in production, often what they find is that like they have to rely a lot on human evaluators, and they have to really spend a lot of time handcrafting prompts with edge cases. And LinkedIn is another example of this, where they really talk about this, where it's all about basically finding the edge case that applies to a given prompt and then inserting that into the prompt to make sure the model behaves correctly. And from that, at Radiant, we ask ourselves, isn't there like a better way we can do this? And I want to propose something that's like sort of very generic, but like, and I will show you a demo in a few moments about like how this can actually be solved in a holistic way. And so the first step is we need to capture the interactions. We need to build a system that captures interactions between LLMs and the applications that are using it, but it can't be like generic across the board. It needs to have the context of the business use case, of the user, of the context that was retrieved, because that is the basis that allows you to understand how your LLM is behaving and how your LLM will behave in production. So this is not just something to do during test and development time, but actually it's more crucial even to do it in production. The next thing is from that, derive key metrics such as, and that are relevant to your specific use case. There's a couple of key metrics you should always know. Something as like, how often does the model not respond? How often is there, for example, a chance of a prompt leak? How long are the responses? Are they actually accurate? Is the response length right for the use case that we're using it for? So if it's, for example, a summarization, usually you have a really good sense of what the length should be or in which range it should be. While for like an interactive like FAQ bot, it might not be as clear. And then from these metrics that you've built out, build specific evaluations. Build evaluations that are tied to the goals of the application, because that is the key to understanding as things change over time, because that allows you to continuously monitor, continuously understand how your application is changing, how it's being used by your audience. And so this is both really important for developers and SREs because they know about reliability, they know what's happening here, but also it allows you to your PMs to understand how are people using this model? Is it working for them? Or do we have to change and do we have to adjust it specifically for the use case? And that's where we then like come to deriving fine-tuning data from the continuous monitoring and the interactions we've captured before. And then we can continuously derive fine-tuning data. And for us, this is what we see as the LLM interaction loop, where it's very much about capturing information at first place, then aggregating it, allowing the people responsible for the applications, the developers and the PMs, to investigate them and then monitor them over time. And one thing I'll say here is there's no magic like model that will come along. Even something like GPT-5 or GPT-6, it might have a really good understanding of the world, but the problem is that understanding, it will be limited in very specific use cases, especially in the enterprise, because there it's always about like the context, and there it's about, can it perform better than a human who has been trained for this job for many years? And most of the time the answer is no. And that is also what prevents you from building like self-evaluating LLMs, because like, for example, in the medical field, often in a very specific field, an LLM might not actually have the sufficient information, it might not have the sufficient context to give a really good answer. This is like sort of the very crucial example to give. And so what it comes about is like, okay, we don't have a magic box. There's not going to be like a magic model that will know everything, at least not in the near short term. So the goal is to build a system that allows us to make our models better for your specific use case. So that makes it that continuously over time, it will build the right model and it will improve it, and you will capture the data that you need to do so, because that is what allows you to then switch from base model to base model, to upgrade from Llama to Llama 2 to Llama 3 to Llama 4 to Llama 5, and continuously fine-tune these base models to make it really good for your specific use case. And with that, I'm going to hop over to a quick demo. So I'm gonna and I will also walk you through like how this works in like a production use case that we have configured here for a specific customer, and then also we'll go through like how our live instance works, and I will go into some of the different details, especially around some of the table stakes that we have to provide. So first off, we have these alerts pulled out. This is what I was describing, where we take logs and we actually turn them into metrics. And then over time, we have that input length and that output length. And we calculate the latency, for example, for each of these models that you're running in each of the applications. What you do then is you go in and you can actually like tie these statistical anomalies. You can find outliers and you can tie them to logs, which then allows you to go in and investigate, okay, what are the specific problems? How often has this happened? And what are the interactions where this has happened? And this ties back to a specific use case. This ties back to a specific context in which this happened. And so again, we can go in, we can see the logs, and we can compare different statistical anomalies. We can then go into our use case view and actually see what the different errors are and what happened with them. And so that allows us to basically understand different problems and actually see them over time. And so now if I go to I also just saw a question. I'll come to that in a second for us. Um, so one thing I'll also quickly go through and share with you is like from our demo instance that you can see. So this is like where we haven't configured the alerts use cases in this case because it's sort of more like a developer instance. One thing that Radiant allows you is to see usage across all your models. This is what I meant with like table stakes, where it's about like you have a centralized plane that allows you to connect to all of your providers. It allows you to bring in a lot of them. You can configure usage limits, things we've seen with like individual providers, but what we see is like at the enterprise level, it's really important to make certain it works across all your different providers such that they can switch and bring in new providers really easily. And it becomes really critical to understand logs and interactions and also have the audit logs, meaning understanding who has changed something in the last time, what are the actions that have been taken, and then also allowing the administrators to decide, in this case, this is tied to our Okta groups, what endpoint access, what model someone has access to, and what endpoint someone has access to. And an endpoint in the Radiant platform, this is sort of our abstraction over a project that we've seen. So here what we see is like, here are the different projects that we have set up here. And what I can understand really easily is like how much usage has been there across different models. What are different like checks? In this case, I have like a webhook check that like allows me to run tone check, understand if the tone is correct for my specific use case. I can easily understand when, for example, a fallback has happened when I needed to switch models to perform a response. And also I have the ability to define, on the one hand, relatively complex routing logic, because at the enterprise scale, what we're seeing is that it is important to not be just reliant on one model. This is like in the terms of reliability, like a much more like traditional microservice reliability, where it's critical to have the ability to fall back and switch over, but also then the ability to say, hey, I want to give my developers freedom. I want to allow them to access a lot of models. I want to allow them to use many things. And then go in and say, here's, okay, an example of like a model, a response. And then also be able to say, hey, I want to compare this to like, let's say, GPT or Mistral. In this case, for example, we have like lots of integrations. So I'll just go with GPT-4. And so having the ability to actually compare two different responses is really important, especially as you think about, okay, which one of those is more useful for my specific use case. And then one last thing I'll give you a quick overview is sort of from a finance and CFO side, we see a lot of interest in the ability to actually go in and understand how different teams are using different models and tying that back to budgets and allowing them to go in and say, okay, hey, this is like enough that you get this much allotted, and also like switch them from like more expensive models to cheaper models, especially as they run them at scale. Classic example is a company where they were running things on on GPT-4 to begin with, and then realized, okay, we can do this for 2% of our requests, but as we scale to 90% of the request, things will break in unpredictable ways. And so that's like a quick overview of the platform. So it's like ties different things together. It ties like the access control piece, the usage piece, the auto logging piece together. But then what it comes in with is the ability to configure alerts for specific use cases and actually tell you, hey, these are like how your model is behaving over time, and understanding if there's issues over time based on statistical anomalies, based on filters that you define yourself, and based on the expertise that you can bring in, because we have seen a lot of our customers who want to bring their own metrics that are defined by the developers working on projects. With that, I want to switch over to Q&A. And feel free to like drop some questions in the chat and I'll like answer them in time. And the first one is from you for us. Yeah, he said there's goal setting is important and there's a lot of stakeholders who all should be included. So in the experience that we've seen, usually you would different parts of the organization care about different problems transparently. And so one thing that we find is that like sort of on the very tactical level, on the very like outcome oriented level where you define the metrics and define the goals, that is very much sort of at your PM engineering lead level. And they care very much about like, is the model giving me an answer for the specific use case? So classic example is like I have a summarization bot that lives in my application that allows me to summarize a bunch of reports I'm getting in. So they care about, is the summarization accurate? But then as you go up the chain, it actually becomes a lot more, I would say, based and like a lot more basic, the questions that people asking. It's less about like, is this model actually working, especially if it's not driving critical revenue, but it's more about, okay, is this working? Like, is this safe? Will it have reputational harm? Where it sort of basically shifts from like upsides of new technologies to more to like downside protection, where people want to make sure that they are not like sort of opening themselves up to a risk. And so what we find is that like there's usually at this stage now, there like a lot of enterprises have an actual AI team, which is usually swamped with requests, and they're like they should be brought in more to be read in, more like as an enablement team that you can help them work and ship GenAI applications. But then you also want to make sure that you include the security and the infrastructure teams, because they will be very concerned about like, how is GenAI used? How will it scale? Who has access to it? And like, that's where you want to bring in someone who reports to the head of IT or the head of InfoSec, that actually allows you to like make sure that it's not just working at scale, but it's also working within the policies of the company. I hope that answers your question. Yeah, so what we find is that basically you probably want to define a few goals ahead of time. And it's not that like the PM doesn't care about, for example, toxicity, making sure that the model um, doesn't like put reputational risk out there. But it's very much that is like a lower priority thing for them, because they trust that the model will already do that. And so it becomes basically very much like having a shared list of goals, but then it becomes like, how do you speak to the different partners? So a good example is like a head of InfoSec will have very different goals that they want to measure for and that they want to qualitatively improve than the PM itself, because they are very much worried about like, can you detect if there's confidential information in this, and can we automatically give an answer from a local model? And so what it boils down to is ensuring that like you have a shared list, ideally with your champion, with your, again, this is someone like the PM or the engineering manager. You come up with a list of like all the checks that need to be in place, and basically also make sure that you don't skip any like things that seem trivial, because what you find is that as you go up the chain, these people will care a lot more about them. They're like, not that they're like, okay, this is like a new feature. Yes, of course, we will have to iterate in it, but like, is this going to cause me any harm? Is this going to be an issue for my company? And that is sort of what they care about. So it's like different ways. It's like, is how I would describe it. I'll give it a couple more minutes if there's any more questions so people have time to ask them. All right, if there's no more questions, then I think we can uh, end it here. Thanks so much, everyone, for coming. And if there's any more questions, feel free to ping me. You have my information both in the event itself, but also in the chat here. And you can find me on LinkedIn or just email me at jakob@radiantai.com. Thanks so much, everyone. I hope you have a good day and enjoy the rest of the conference.